A quantum computer is a physical computing machine, the principle of which is based on the phenomena of quantum superposition and quantum entanglement. At the moment, our usual computers could be compared to candles, while quantum computers would be comparable to incandescent lamps. Quantum computers will be a breakthrough in modern science and our concept of computing speed, because a quantum computer spends only a few seconds on a task that would take several days to calculate with our usual devices. The prototype of modern models of quantum computers was Turing's quantum machine. Any quantum algorithm can be represented as a partial case of a quantum Turing machine. From the first time such machines were described in David Deutsch's writings, he assumed that quantum gates can work in the same way as classical binary logic elements. A quantum gate is a basic element of any quantum computer, which converts any input qubit states into output states according to a certain law. The main difference between a logic element and a quantum gate is precisely that the gate operates with qubits subject to quantum logic, and the logic gate operates with ordinary bits. That is, it converts input logic signals into output logic signals. The gate operation logic is based on bitwise operations with input digital signals as operands. Qubits solve the problem of memory shortage. It does not matter whether it is a magical vacation photo or a new mathematical model of the development of an epidemic. This piece of information uses properties of quantum physics that allow it to remain in a so-called superposition. A qubit can take any value between 0 and 1. It has the properties of the entire spectrum and can have values such as 15% 0 and 85% 1. Theoretically, this allows you to save much more information or speed up calculations. But at the same time, a lot of problems arise that are difficult to control and even understand. Another feature of quantum computers that allows additional scaling of computational power gains is the use of quantum entanglement. This is a state where two qubits are connected to each other, and every time we observe one of them, the other will be in exactly the same state. Entanglement allows qubits to be grouped into even more efficient units for recording and processing information. However, the larger capacity of the disks and the variability of the information transfer methods may not be such a big advantage, considering the errors. The fact is that quantum computers require a very calm environment. Any wave, electromagnetic or thermal influence, can cause an infinite number of errors, and then the transmission and reading of information using such a computer will become impossible. For classic devices, the error probability is about 1 in 1017 bits. In the case of quantum computers, this is still one of several hundred. And this is in a situation where quantum computers work in the most isolated conditions, and at a temperature of negative 272 degrees Celsius, which is slightly above absolute zero. Any temperature fluctuations, changes in the electromagnetic field, and even movement destroy the entire calculation. Another problem is the instability of quantum states. Every time we measure or want to disturb a quantum state, it returns to one of two positions, 0 and 1. In this case, the quantum state will decay. This process is called quantum decoherence. Today, the question arises, what can quantum computers be used for? Just like 20 years ago, people asked the question, what can a smartphone be used for? Of course, there are already some plans and assumptions, but the most interesting directions for the use of qubits will probably become clear when quantum computers become widespread. Cryptography is one of the most popular fields where quantum computing is most often used. The thing is that it will be a method of transmitting information in a very secure way, and the security is not based on the complexity of computing processes, but on the laws of physics, which will give confidence that it is impossible to be listened to, spied on, or hacked. Security in this case is guaranteed by the very physical properties of qubits, which cease to show superposition features as soon as they are observed. So any attempt to intercept or even copy the encoded message will simply destroy it. Quantum computers may also allow us to better understand natural processes. The chaos of superposition much better reflects, for example, mutations in DNA, and therefore the development of diseases. Quantum computing is already being used today to create new drugs. It should also be said that quantum computers will be used to simulate various situations and find solutions to problems, including medicines and vaccines. For example, during epidemics, when a faster calculation of options is needed, one can use quantum simulation, which cannot be performed on a classical computer. Given the significant interest and funding in quantum technologies from both civil industry and governments, it is expected that these technologies will continue to develop. and new quantum applications will become available within the next 5 to 10 years. This should involve not only interaction with large technology companies, but also especially with startups, universities, and research institutes, because it is they who play the main role in innovation in these new technologies. As technology continues to develop and move forward, many companies might be looking for the right technology partner to help their company. Swan Software Solutions creates custom applications to help businesses succeed. To discover more about how we could help your company, contact us to schedule a free assessment.